Okay. For the last two sessions, we are ended to the part of type of isomerisms that I was tell you that there is a constitutional isomerism, or for some time we can say that is structural isomerism, and the second one it was stereoisomerism. So from that of day on these things, I was introduced that we're going to discuss in depth. There are different forms that are found in constitutional isomerisms and stereoisomerisms. So for today, try to draw attention on this case in order to understand what the concept is being on a constitutional isomerism or structural isomerism and stereoisomerism. By starting with the structural or constitution structural, this is structural isomerism. This we said that it's the existence of the same molecular formula of the organic compound. So this is the existence of the organic compounds of the same molecular formula but different arrangement of bonded atom. And from this we try to look on what the bond is bonded, and it is categorized into three forms. So this constitutional isomerism or structural isomerisms, we said that is the existence of the organic compound of the same molecular formula but different arrangement of the bonded atoms. So it means that the constituents that exist between the organic compound, it can be arranged in the different forms, but the structure seems to be the same. This we call structural or constitutional isomerism, and it is categorized into three forms. Which are they? We start with the first one. The first one is about skeletal. We call it skeletal. Sometimes we can call sequential or chain isomerism. You see, so this is skeletal, sequential, or chain isomer is the category of constitutional isomerism, where the compounds of the same, this we said that are compounds of the same molecular formula formed but different in connectivity. Of the carbon chain. So when we say skeletal, sequential, or chain isomerism, we say that this is the form of structural isomerisms where compounds of the same molecular formula but different in connectivity of the carbon skeletal exist. So from this we can take an example. When we say skeletal, so from this statement maybe you can't understand, but you can understand much when I give you an example. So the example of the skeletal or sequential isomerisms, it can be like that way. This one is the example of skeletal. CH2, sorry. This is butane. You can say N-butane. You see? But for some time, this arrangement, it can be changed into another form. So we say that this sequence, it can be different arrangement from its carbon skeletons. So sometimes it can be this one may be the first. Sometimes it can be seems as CH3, CH3, and here is CH3. You see that here we have 4 carbons. We have this one carbon, we have this one carbon, we have this one carbon, we have this one carbon. But any part of naming it seems to be different. This one is seemed to be the carbon. It seems to be a compound with 4 carbons. So this one have 4 carbon, and this one also have 4 carbon. So from these 4 carbons that exist between 2 molecules, but in a part of naming here it can be different. Why I say this one it can be different? Since when you back here you can name this one is 2-methyl, since this one is the major chain. That is, there is 3 carbons in the chains, but here there is a attached group. This one is the attached group, this methyl. So it means that by naming we can start by say 2-methyl propane. You see, this is 2-methyl propane, but this is N-butane. So it means that this and this have similar chemical formula, since they have 4 carbons, even if the number of hydrogen is similar, but the different in part of naming and the arrangement of this one and this one is quite different from its chain. Since you say it is sequential, it means that the sequences can be changed. So from that here we call this one skeletal or sequential carbon chain isomer. Together. So the second, we're going to look about the second form of structural isomerism is about we look about the fraction group isomer. Fraction group isomer. This fraction group isomer, we try to observe how the fraction group is being arranged from the compound. It means that the compound it can be the similar but different in the fraction group. So we said that this is the form of structural isomer where compounds of the same molecular formula but have different function group. So we see that the chemical formula is similar. It means that if there is the number of oxygen, it seems to be the same, the number of hydrogen is the same, the number of carbon is the same, but until the end, when you arrange it, it comes to be different from those compounds that is existent from the same formula. We can take an example here of functional group isomer. Example. The example is this one, that we have the compound, this one, you see, this is the compound that we have, but you can see that this can be exist in two form different, that we can have the first formula, that is the first one, this one, and this one, that this one is ethanoic acid, common name ethanoic acid, and also we may have the second one, this one is the first, and the second one we may have this one, CH3, maybe oxygen here, and here oxygen, and here is hydrogen. So this one we can name as ester. This is ester. That is, for some time we can say that a methyl methanoate. This is the methyl methanoate. You see? So it's methyl methanoate. So from that we can see that when we say function group, it means that the number of carbon, there are two here. There is carbon 1, carbon 2, and also when you back in this function group in a second, there is 2 carbon, 1 carbon, second carbon. And when we back in part of oxygen, we have this one, 1, 2, and here we have 1, 2, and also the last hydrogen, and here last hydrogen. So it seems that the chemical formula is the same, you see, but the structure formula is seem to be different. So from that is what we call the functional group isomer. This is the among of the second form of structural or constitutional isomerisms. So now we're going to back to the last but not least from the part of structural isomerisms that we call positional isomerism. So the third one is positional isomerism. Isomer. I'm going to look about the position isomer. This will say that is the form of constitutional or structural isomerism where a same molecular formula, where a organic compound have the same molecular formula, same skeletal carbon, but different substitutes or function group. So it means that this one have same molecular formula, same molecular formula, also the same carbon skeletal, but different substitutes or function group. So it means that the carbon have the same carbon or carbon skeleton have the same molecular formula, but the difference is the substituent that is attached to the chain of the carbons in the fraction group. We can take an example. We have an formula of this one. Example of positional isomerism. We may have the compounds which have formula of carbon 4, hydrogen 10, and oxygen. That is, we call what? Butano. Butano, you see? So we can start on the part of fraction group. Since I said that we can base in substitution or in fraction group. So we can start to the part of skeletal chain of the carbon that is based on substitute. So we based on substitute. From this formula, we're going to use substitute now. From this formula, we use substitutes of attached chain. From substituent for attached chain from this compound, we can make like this one. It means that the first one, we have the formula like this one. Sorry, we have the formula like this one. That is a butane 2. This is what we call butano. Butano, you see? But sometimes we can say butane 1O. And the second again, the second, we can get the structure like this one. It may be like this one. Okay, the second one, it can be like this one. CH, this one, CH3, CH2O. That is we call what? 2-methyl. Since here we have a longest chain in this one, so it will be 2-methyl. But the longest chain is propanol. It will be propan 1O. You see? So from that, the structure of this one and this one, it seems to be different from butano and this one. So this one, the longest chain is propan, but this one, the longest chain is butane. But the chemical formula, it seems to be similar. But for some time, you can get the structure formula like this one. From part of fraction group, you can obtain this one. That is a CH3 carbon, CH3, and here is OH. That's we call 2-methyl propan 2O. You see? So this one is the among of the fraction group that you can obtain from this one. And also we can get the last one. Again, we can get the last one, that is this one, CH3, CH2, CHO, and CH3. That is, we call what? We call butane 2O. You see, from the first example, the second, the third ones, and the fourth ones, it observed that the structure formula seems to be the same. You see, since there is 4 carbon, but in part of naming, it seems to be quite difference. So this is what we call position isomerism. So this is the first types of isomerism, that is constitutional or structural isomerism. So when we say constitutional or structural isomerism, it will be the similar. So here we're going to look about the three categories, that is the skeletal or sequential carbon chain isomerisms, or sometimes we can have a second one, that is the fractional group isomerisms, and the last one is position isomerism. So I like to say thank you, and for the last sessions I will continue with the stereoisomerism. So make sure that you continue with this part in order to make good correlations from these organic concepts, in order to make a good understanding to the coming sessions. I like to say thank you.